Hello there, ladies and gentlemen. Today we're going to start into Chapter 4. We're going to do 4.1 and 4.2 together. We're going to talk about triangle sum conjecture and properties of special triangles. Real short today. Just keep in mind, triangles are very useful in building structures because of their rigidity. That means their strength and their ability to hold a lot of weight and disperse it. This is why they're used to build bridges and a lot of buildings and other structures you'll see. You'll notice triangle shapes to help disperse weight. You'll see them in here's a picture like a walkway or in sculptures. You'll keep in mind that you'll see these in some things, but some things they're hidden within the walls or the ceilings, and that's just a great shape. It spreads out the weight. Okay, so the conjecture, and we know this, the sum of the measures of the angles in every single triangle is 180 degrees. We know that. One thing we can say is if two angles in one triangle are equal to the measure of two angles in another triangle, then we know that that third angle in each of them is also congruent. So if I have a triangle here and a triangle here, and this angle is 45 degrees and this one is 65 degrees, and this one here is 65 degrees and this one here is 45 degrees. We know that because every single triangle adds up to 180, this angle and this angle both have to, or I should say not add up to, but should equal 70 degrees because both of the triangles need to be 180 degrees. So if two of your angles are congruent to two angles in another triangle, we know that third angle is also congruent. Let's just keep in mind when we're dealing with some lines here about angle measures. When we have two angles that form a straight line, that's 180 degrees right there. We also have the two angles over here, and they form 180 degrees. So if we look at all of this together, that whole circle, that's 360 degrees. Circles are 360 degrees. Semicircles or the linear pair or supplementary are all 180. You're going to need that when you get to your assignment today. All right, let's talk about isosceles triangles. We have different parts. We have the vertex, we have the base, and we have the legs, which are the ones that aren't the base. And then that leaves us to say that these two angles, this one and this one, are both base angles. Now, your base is always across from the vertex. The vertex always occurs in between the two congruent sides. So this is and this is going to be the base. Even if it's not sitting on it, it still is considered the base. These two here are still considered my angles, and my legs are still those two congruent sides. So no matter what way it is facing, those are always going to be true. So if a triangle is isosceles, then its base angles are congruent. So if we think back to our picture, if it's isosceles, so two of the legs are congruent, these base angles here are also congruent. We can say the converse is true. I can say if I have a triangle and its base angles are congruent, then automatically it's going to be isosceles. And the lines which are going to be across from those base angles are going to also be congruent. So that makes it an isosceles triangle. All right, and here's your assignment. It's real short, only 15 problems, and we will go through it tomorrow. Thanks, guys.